Now here we talk about fluid. I believe you remember the first experiment you had density. So density of a substance we divide as rho equals mass over volume, or mass per unit volume, which is kilogram times meter cube. There are different density values on table 1 chapter 11. So let's say you're squeezing the pressure, which is P equals F over A. Then we'll talk about the pressure in a static fluid, which is figure 11.5 on page 264. Alright, this is the fluid here, and we're taking a small piece of a cubical type, the cube actually it is. You have cross-sectional area here, top and bottom, that's what we're trying to do, and figure out P1, P2. So the force in the direction of Y is this. Look at this. You have sum of all the forces equals P2 minus P1 times A. So it is P2 times A, cross-sectional area. Take away P1 times A and take away mg, which is the weight of the fluid. And after you simplify it further, m equals rho times v. So you have P2 here equals P1 minus rho g, which is rho g h. Now look at this diagram. This is Pascal's principle, where two different tubes are connected. One is a smaller diameter, or is a little bit larger diameter, and you put pressure from the top, and both are open to atmosphere. And what happens here, we're considering the force F2 and F1. So where F2 will be equal to F1 times A2 over A1. That is a simple equation, which is Pascal's principle. All you have to do is remember that and how to apply in solving problems. The last topic we have is Archimedes' principle. This is Archimedes' measurement you did in density measurement, where you have the buoyancy force, like you jump into a swimming pool, you try to push up your body by the force which is by the displaced fluid. So that's the buoyant force and buoyancy. So FB equals P2 cross-sectional area, take away P1 cross-sectional area. So difference of these two, pressure times cross-sectional area, will give you the difference in force, which is rho, g, h, and a. So we can define from there the buoyant force Fb equals the weight of the displaced fluid. So this is a very simple equation. So you will have some problems you got to do, the homework problems. So now as you see, excuse me, we have covered from chapter 11.1 to 11.6, which I covered for chapter 11. Thank you. Good night. I haven't finished checking your exams yet. It will be in a couple of days. I'll do it. And your midterm grades for all of you is really good. I'm impressed.